You may recall that I mentioned the vertical line test as a related concept to functions. So the point of the vertical line test is it determines if a graph shows a function. You may also recall that the definition of a function is that each element of the domain matched up with exactly one element of the range. So the way to use the vertical line test is for a function, a vertical line will only intersect the graph once. So if it's not a function, then the vertical line could intersect the graph, say, twice. So let's look at this in practice. So if I have the graph of y equals x, so my equation here is not in function notation. So I'm trying to debate, is this a function or not? And so put it on my graphing calculator, and turns out that the graph gives me this line like this. Okay, so what I notice is that, and I'm going to use a different color here, if I would draw a vertical line, any old vertical line, anywhere on this graph, those vertical lines, any of them, only ever meet the graph 1. So yes, this is a function. All right, so let's take a look at a second one. So for this one, we would have the equation that y squared is equal to x, and that would be a pain to graph on your graphing calculator, so I'll just draw a graph for you. And so the picture of this graph looks like this, like a sideways parabola. And we'll try out our vertical line test to see if this equation is indeed a function, because right now it's just an equation. It doesn't have function notation in use, any of that. So if I draw a vertical line here, it doesn't intersect at all, so that's not helpful. If I draw it right here, I probably can get it that it would intersect once, but this one intersected twice. Or if I draw it right here, this line intersected twice. So when I look here, it says for a function, a vertical line will only intersect the graph once, and this intersected twice. So that tells me that no, this is not a function, because that line went through twice. So I think graphs turn out to be pretty easy because of this test. Let's give you one more, and then we'll start looking at the equations, because equations by themselves without the picture are, in my mind, a lot harder. And so it's that old picture's worth 1,000 words. In this case, definitely the case. So let me see if I can switch pen colors. I'm trying. There we go. All right, so if we had a graph, and it was this. What do you think? Do you think that is the graph of a function or not? Well, the equation would be y equals the square root of x. I don't know if that helps you or not. I'm hoping that you decided that it was indeed a function. So this one is a function. I think that it's easiest to decide by looking at the graph. And on that graph, if I draw any old vertical line, any place here, that I can draw it over here, doesn't intersect at all, so not helpful. But anytime that I draw it that it meets the graph, it meets the graph exactly once, and that's the criteria for a function. So what I'm going to do is erase the slide here, and we're going to look at how to tell if the equation is a function. So the vertical line test determined if the graph was a function, but what if I just have an equation instead of a graph? So erase, ta-da, and let's see if we can write. So how to tell if equation is a function. Or not. So for me, there are 4 things that I look for, and if it has any of those 4, then it's not. So it's not going to be a function if it has first thing, an even exponent on y. So before I erased, we had as an example the equation y squared equals x, and that was not a function. So because this is an even number and it's on y, it's not a function. Now, amazingly, odd exponents on y can work out just fine, and even exponents on x work out just fine. So it's only if you have that even exponent on y. So second thing is if you would have an absolute value on y. So if I give you an example there, if we use the straight lines for absolute value of y equals x. This has the absolute value on y, so not a function. These that are not functions are really hard to graph on your graphing calculator, so I don't want to ask you to go graph it, but if you would graph it, you would get a graph that is like a sideways V shape. And you could see that that graph does not pass the vertical line test. So because a vertical line would intersect twice, you would determine this is not a function. Number 3, something is not going to be a function if there is no y in the formula. So if I have, as my example here in a box is, I have x equals 2, yeah, there's no y, so not a function. Again, you're not going to be able to graph this on your graphing calculator, but the graph of it would look like a vertical line at 2. And so, again, this does not pass the vertical line test because I could put a vertical line right on top of it and they would intersect in infinitely many points. So that one's not going to work. And the fourth or final one, and in some ways this one's the trickiest and the most obvious at the same time, but if there's a plus minus in the formula. So when we were looking at the mappings, we had an example that we had y equals plus or minus square root of x. And so that plus or minus is our key indicator, not a function. So in some ways, I think this one's the easiest one because that plus minus immediately violates the definition. Something with a plus minus is going to give you 2 separate answers, and so it's not going to map every element of the domain to exactly one in the range. That's definitely not going to work. And if we looked at the graph of this, we would end up with a graph of a sideways parabola. And that would obviously, again, not pass the vertical line test, so not a function. Now, in functions, so let me switch pen colors if I can. We'll go with blue. In a function, the y can be replaced with f of x, that function notation. And so I can quickly see that in the first example here, where there's the squared, I couldn't put f of x squared. That is weird notation. That doesn't work. And so that's not a function. I can't do that replacement of the y with an f of x. So it's not going to be able to be a function. And that kind of helps me. Like if something is happening to y, it's most likely not a function. Same deal with the second one. The second one, there's this absolute value on right over here, absolute value here. And so I'm not going to be able to replace that with f of x. The third one, there's not even a y there, so I can't replace it with f of x. And so these are not functions. Now, that's why this fourth one can be the hard one, because in the fourth one, I could replace the y with f of x, but that plus minus violates that one-to-one. So let me give you an example that is a function. Keep losing my pen here. There we go. So if we had y equals x squared plus 7. Here the exponent's on the x, so that's good. And I could see that this would be the same as f of x equals x squared plus 7. And I can clearly replace the y with the f of x, so yeah, that's a function. That one's going to work out just fine. And my graphing calculator is set up to work with functions, so that one's going to be easy to graph. And I could graph that and I could see that it's a parabola shape, passes the vertical line test, and it's all works out. It's a function. So only when one of these four things show up do you have something that is not a function.